Mark, can you still hear me?
We're good and we're live.
Michael, can you talk just to make sure we can hear you?
I feel like I'm talking and that you can hear me.
I can hear you. Thank you, Mary. And Mary, could you lock?
And there I am.
There we go. All right. And if anybody could get to the Slack channel and just confirm that you can see Michael's bald head and goatee happening right there. Hey, you're looking good, man.
It's a super cool delay over here. I'm watching myself do a bunch of stuff in the past. It's like me. It's like having a time machine.
You know, Derek Weeks, my partner here that puts this on, we always look forward to your session because we know it's going to be dynamic. We know that you're going to have something real to say. So I don't want to take up any of your time. Let's get to it. But let's put your deck up. And I might interrupt you if you say something outrageous that I have to jump in.
Well, there's always that, right? There's always a possibility that that's going to happen. And if it does, well, it's basically, I mean, I blame you, man.
There you go. You're up and running. Thank you. I'll be here in the background.
Cool. All right. First of all, thanks everybody for showing up, for putting this on, for putting up with my crap and all the other things that I'm very likely to say and do and be mean about and everything else. A couple of promises ahead of time. I actually wrote this presentation shorter than I normally do so that I can maybe not roll over for time, but it does happen. So let's move along. Today, I'm going to talk to you about one of the most basic elements of what I consider to be software development, and that's repository management. And repository management specifically in the terms of having a caching repository manager that you can use. So my name is Mykel Alvis. I run a consultancy where we do DevOps consulting, if you want to call it that. But my title is frequently coach. I've been in software for a little over 40 years. I started this when I was around 10, not my consultancy. Obviously, that'd be weird. But I've been in software for a really long time, and I've made a bunch of really terrible mistakes, and I have a lot of really nasty scars. So this is where a lot of this came from. I tend to focus on producing delivery through builds. And by delivery, I mean delivery all the way to the end. And by build, I mean build in the way that we typically think of builds. I drive my customers and my teams and my colleagues to produce things directly through a build system, and more importantly, to fail if that build should fail for whatever reason. And depending on who you ask, I may be an idiot or a genius, but neither of those things is true. I'm neither an idiot nor a genius. I'm just a regular person who happens to have done this for a super long time, and I have a whole bunch of information that suggests that this is important. So today I'm going to really talk about two deficiencies that repository managers can help you with. They aren't necessarily the kinds of things that people would normally talk about. This is probably a very kind of higher level talk than I might normally do, but let's see, it's not really a culture talk. It's not really a technical talk, somewhere in between. So I'll do what I always do, which is tell you all the things you need to know about what I'm about to say. So if you want to quit right now, that's cool. The lead for this is please use a caching and preferably a security scanning artifact repository in your development process. I hate those people that read their slides, but that's me reading my slide. Please do that. That is if you take nothing out of this today other than that, then I have fond memories of this already. So the question then is, what is a repository manager's purpose? A repository manager lets us store collections of bytes in a way that lets us reference them across time. Like we can talk about them temporally. I have some version of a thing. People do this in a bunch of weird ways. They'll do shares on file systems. They'll do content management systems. And these things are also artifact repositories to a certain degree, if you think about them in terms of the artifact being just the content. But the important part is having a namespace and a temporal namespace associated with it. One of the other things that a repository manager's primary purpose is, in my more of my opinion than a point of fact, is that they give you the option of not being able to remove them, of making it basically write once, read forever. And in that case, when you build a thing, as long as you don't try to build the same thing again, you get enforced immutability. And that's kind of important for a lot of the things that I talk about and a lot of the ways that I work. Repository managers in the caching sense give us a way to proxy artifacts from the internet, because not having your dependencies accessible to you is the worst. And they also give you a place to look when you're talking about your security scanning. If you happen to be in the business of building software, you have a bunch of stuff that you probably use, and having an easy way to target what those things are is important. Now, big deal, right? So if you're here, there's a decent chance you at the least heard of proxying, proxying and caching repository managers. Nexus is one. There are others. People in the JVM world are very used to having dependencies resolved. This has been a thing that we've done for a super long time. I don't know who was before CPAN. There might have been some repository mechanisms before CPAN, the Perl repository resolver. But I don't really know anything about that. I do know that CPAN had a lot of trouble when I used it last, which was a super long time. The JVM had a lot of trouble with it across years. There was a lot of growing pains associated with that, a lot. Even in my recent memory, which is probably like way before a lot of people have actually been working on it, but not important. So the problem with that is that the JVM has always resolved dependencies since basically like 2001, so just a few years into the Java lifecycle. But it hasn't always resolved them correctly. Frequently, it resolved them correctly, and usually it resolves them cleanly. And I would say that in 2019, it's a pretty solid bet that you're going to get it done consistently, which is actually the most important thing. Even if it's wrong, having things resolved consistently is actually important. Now, for people who don't use dependency resolution in your JVM tools, I don't even really know what to say to you. I'm super sorry. I'm sorry that you have somehow missed the boat on this. Whatever, the boat is still at the dock. Go get on it. But trying to resolve those things in other languages if you think you have a problem with it now, then try to go do it in Python. Try to resolve dependencies in Python in multiple systems. Try to resolve the same dependency set for a very unique set of artifacts in Amazon Linux 2 versus Windows. I'll just wait here for the next 45 years while you try to do that, because you're not going to get it. It's not going to work the way you think it will. Those languages have, and I'm going to make everybody mad right now, really crappy dependency resolvers. Their satisfiability as solvers they're just not great. This has been true for a long time. The JVM rules have been true for most of 2 decades. And the truth of the matter is that all of these other languages and all the other types of dependency resolvers are getting better all the time. Whether it's good or bad or whatever, if you don't like it, if it makes you angry, it doesn't matter. It's getting better. We're getting better at this, I think. But frequently, resolution of dependencies is an ignored constraint in development. And the reason I know this is because I have like literally dozens of people that I interact with on a regular basis who don't understand how to manage them. They don't even understand the concept. I am frequently describing conceptually what dependency management means to people. A lot of those people are new, they're young, or maybe not so young, but young in the field or whatever. And they have a tendency to be, things seem to be tough for them. The other thing that I see when I talk about people who do understand about dependency resolution in the non-JVM environments, in the other languages, Python, JavaScript, these things, everyone ignores the history and the lessons that were learned in the JVM environment. They just do. You want to talk to somebody about dependency resolution in JavaScript, they'll talk to you about PyPy all day. They'll talk to you about Ruby gems all day. They will never talk to you about the Maven resolver. They'll never talk to you about Ivy. They won't talk to you about Maven Central. And I have my suspicions why this is, but those suspicions are very unflattering. So I'm going to go ahead and not bring those up. But ultimately, it seems like a lot of these dependency resolvers and managers kind of ignore the pain that Maven went through. I heard Brian Fox talk on a podcast last year about packaging, and he basically said the same thing. It was just like, we did all these things, made all these mistakes, and it just looks like nobody's paying attention to that. So yeah, whatever. Can't really help you if you won't help yourself. So I'm going to launch this into a couple of stories, and these are all lies, by the way. They're real people, but not real stories. We're going to talk about Dan. Dan is a guy that I know. He puts cat pictures on the internet. So Dan is not a real person. He is a real person. He's not a real name. They didn't do cat pictures. It was something else. This was back in 2016. That date is super important. It is when I wasn't a consultant, so I wasn't getting paid to do this. I was just doing it because I happened to like the people there. Had a bunch of JavaScript developers, a bunch of Ruby developers, did some cloud deployments, had what he called a pipeline. This seems great, right? So Dan's team writes software. They use editors, they fix dependencies, they do builds and tests and blah, 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 blah. And hopefully they make some money at the end. That was his point. He ran a business, so he wants to make some money, and that seems great. So this is kind of so I'm a really terrible artist, as you can see. He had some Rubies and JavaScript. He said that his pipeline looked like this. He fed that into a CI/CD thing. He ran some tests, and if they passed, he'd package it and deploy it and send it to his customers, and that seems right. But he missed this part. Everybody knows this part's real. In between the source code editing and the CI/CD pipeline, the internet vomited 10,000 lines of Ruby and JavaScript into his pipeline. He had dependencies, and he resolved them with the available resolvers, and they just piled into the file system of whatever he was working on. And this is fine. It's actually the way you want it to be. It's great. And I mean, this is fine, like really fine, not like the dog in a room on fire fine. Really, seriously, it's fine. It's really the way things are. So I looked at him and I said, you got some things coming down the pipe, man. It's going to happen. I don't know when, I don't know where, I don't know why, but it's gonna. And you got to bring the first thing you need to think here is that fine today is we looking back, the retrospective script is great. We can see things that happened. But I told him, I said, you could use a proxy and cacher. You could, there's a thing you could do. And he just told me they didn't want to do it. And I said, we had a conversation about how much it costs, what it was going to be, what it's going to run. And he just didn't want to do it. And that seems okay. Because I can't tell people how to live their lives. I can only tell them, what I see is coming down the road. So I stopped. He's my friend. I didn't want to make him mad. So I stopped trying to be helpful to him. And then remember what year it was. It was 2016. This happened very early 2016. Does anybody remember what happened in 2016? Say in March. If you're a JavaScript developer, that day, March 20-something or 16th or whatever it is probably burned into your mind. But it was the day the internet died, briefly. And LeftPad was a thing. Obviously, if you want to figure out what happened on the 2016, you can go research LeftPad. LeftPad got pulled out of the NPM repository. It was a required dependency for another thing that a lot of people depended on, and a lot of things broke. But for the person that I cared about in this, the effect was relatively trivial, except for one thing. It got him thinking. And so we talked again, and he installed a practicing repository manager. And I helped him along a little bit, and his developers are happy. And that's the end of the story. They, as far as I know, remain happy under the circumstances. Now, this is not a Marvel movie, so there's not an end credit scene where I tell you about how, and then somebody came along and nuked his repo manager and all that. No, none of that. He's happy. It was the end. It's kind of as simple as that. But I have another story. And it's not a worse story. It's the same story. So there's this person I'm going to call Ted. Ted is an actual person, as Dan was an actual person. He delivers actual important stuff. I don't think that, Dan's team, the things they did, they thought were important. That's great. But Ted delivers things to very, very high dollar, high penalty failure situations. He does all the stuff that we talk about in enterprise software, test-driven developer, blah, 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 automated delivery, had metrics. But he had this weird requirement. A really weird requirement. He had a thing that he needed. Now, they wrote software, just like Dan's team, editors, dependencies, tests, package, deploys. So they made a lot of money. But he had this deficiency, this thing that really kind of irritated him. And it was understandable. He needed a specific set of bytes. And that specific set of bytes changed over time a lot. A lot. So he used a common tool chain for managing the common dependencies. He had an uncommon dependency that he didn't have as part of his tool chain. So he had to kind of do it all by hand. And the process for doing that was extremely painful for people. They hated it. They hated doing it. They didn't like it. They did it wrong. They did all the things that I talk about when I talk about how terrible people are when you put them into an automated process. They just did all the stuff. People got sick and they forgot and they did it in the wrong order and blah, 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 blah. Now, so I tried to help again. And I'm not like what you'd call normally a very helpful person. That's not, I don't go out of my way to help random human beings, although I have done that a lot more lately. I don't know why. But it turns out what he needed to do was store this little artifact that he wanted for potential retrieval. Now, his team was mostly Java and a little bit of Clojure. That actually matters a little bit in the question of caching repository stuff, but not super much. He used Nexus, and he did formal releases using, he built the tool using Maven, and he did formal releases, which is the way that I typically tell people to do. If they ask me how to do it, I tell them to do that. Now, he just didn't know that he could make a new type of dependency. Normally in Maven, when you've got a dependency and any of these tools, any of the JVM tools, your dependencies are almost always jar files. They're just compiled packages. They're a priori generated code that has been packaged and stored and has a version in the form of a GAV, and you just know it. Right, you just go find it, you install it into your dependency resolver, and it just does it. He had a thing that didn't fit that. So what he did was he wrote a plugin that built that little artifact. And I say he, I mean, we, which I mean me, but that's important. So it fed very neatly into the pipeline, and his problem was solved, and it was fine because he already had the proxying resolver, and that proxying resolver also cached and proxied his new interesting dependency because it fit within the system. And it's as simple as that. It wasn't simple. Let's be clear about that. Writing custom packaging types in Maven that aren't zip files has been, well, it's gotten a lot easier over time, but up until, pretty recently, it sucked. I mean, like within the last 5 or 6 years when it got to be not sucky. Before that, it was a nightmare. But dependencies getting resolved in Ted's arrangement worked fine. The manager maintained his release integrity, and that's the end. Again, no Marvel end credit scene where stuff goes bad. This is the way for handling certain kinds of problems. The caching proxying manager handles cached dependencies if someone decides to do some awful things. So let's talk about the conclusions, and we're only in the middle of this, but you can talk about the two kinds of dependencies deficiencies that I see that we're talking about today that I said at the beginning. The first kind is there's an external risk taker on the internet. LeftPad was this. The external risk taker in this case was them, and was everybody in the stream, because NPM doesn't have what I'd call particularly hardcore rules about that. They have gotten better. They've gotten better recently even. They continue to get better. They're always getting better. But they didn't learn the lessons from the beginning from other people who had these problems. So, it's going to be a while before that's really taken care of. The second kind of deficiency is when you don't actually own your own dependencies, right? And the caching mechanisms handle this as well. But if you had to deal with external production of dependencies, like if you had to have a flash drive and copied onto a file system and that kind of stuff, like that just makes me break out in hives to think about, when in fact that's just a bucket of bytes that has a name across time. You can talk about it with a version, and like you can even use the timestamp as a version, for goodness sake. You're never going to travel backwards in time directly. So there is a problem. There are sketchy people on the internet. And those sketchy people might take your things away. They might take risks that impact you. The March 2016 event indicates that this is true. There's also you who takes risks. And there's a credit reporting industry, a company that will be happy to explain to you in front of Congress how they managed to do that. Transitive dependency graphs are rarely analyzed fully. And by analyzed fully, I mean analyzed by a person for value. We as developers, especially in the JVM and even in the non-JVM worlds, we just go, hey, I got this dependency and it has 4,000 dependencies on it, and I'll just go download the internet and I'll just run because I don't want to worry about that problem. You have to worry about that problem. That's your job, is to worry about that problem. And do we learn from these mistakes? Well, sometimes, I guess. But owning your playing field is important. Your dependencies can go, and managing a cache helps. Nothing can keep you from screwing yourself over, but you can try, especially if you have a solid process in place that you have to deviate from and you can feel the deviation happening. If your cache has all the stuff you need, you can at the very least get back to the point where you screwed up before. And good tooling exists that scans utilization of that cache for vulnerabilities and security. These are just things that we have to do. DevSecOps just revolves around this. The weird part is, except for .NET, well, kind of for .NET, because NuGet's kind of a thing. It's a thing, but it's kind of a thing, and it certainly isn't any better than some others. It seems only slightly popular. Like as I said, I have like piles of humans who just go, nah, we don't bother managing our dependencies. We just get them every time we download, every time we run a build. They just go download from the internet, and it just makes me wonder, like, do you just not care? You know, do you just not care? So I'm going to talk about this, and I got a couple of things I got to do. I got about 10 minutes left, I think. So there are many valid ways to build software, many, but I'm going to talk about two that I think are really the dividers as how software gets built today. One of them I call a priori, which means I built it at the beginning. So the intermediate binary form and intermediate assembly of the package is I built my dependency before I built my application. I tested that dependency independent of my application. And at the end, I just assembled it all. Usually those are tested, but even if they're not tested, at least they're fixed in time. This is how the JVM works. Clojure doesn't always work this way, but it still uses an intermediate form. Weirdly enough, you know, most of the other tools, a lot of the other tools in the world that people actually use, Ruby gems, Python eggs, Docker containers, these are all basically a priori built systems. You don't, you know, dump everything in the middle and build it all at once, which is what I refer to the Amadeus Ray. Generally acquiring source from source code control, run and build all your tests at one time, just as one large block. Final result is usually what you're looking for, and the result is guaranteed to be binary API compatible. None of your dependencies can fail to talk to each other because the compiler demands it. This is the way Going does, and Rust, and a couple other things, which leads me to my next story, which isn't really a story, which is the crap pile that is Golang dependency management. I write some Go, so you may not write Go. You may not think this is real. You may not think that it is actually the storm that I believe it is. But you know, this is the thing in the world that I know. So it's having a little trouble with this. Now, it seems like a lot of Go developers just absorb that pain because it's okay. That's just how Google told them to do it in the beginning. But as I can tell, there are at least 4 ways to go with doing dependency resolution. And because Go is primarily the Amadeus Ray kind of build, you have to catch all the source code in the right way. There's not an intermediate binary form. There's not a pre-compiled, pre-tested version of a library. There are some arguments going on even now about whether or not you can, you know, whether or not packaging is handled appropriately with Google, and, you know, sure, whatever. I'm not in those arguments because, as far as I can tell, the way that it has really turned out is that they're not sure how to do it, and I don't have any influence over them, and I don't really want any influence over them. I just want there to be a way to handle this properly. So the reason that's a problem is that using a dependency manager for source code based dependencies is actually super hard, especially if your source code manager is not, even if your source code management system allows you to rewrite history, which a certain source code management system that is very popular does right now. So the one that no matter what language I use, it seems hard. We might be able to get this worked out, but there's a thing you need, and you need to know how you're going to do it, and somebody needs to decide it. And it's not going to be me, and it needs to be the community, and needs to be the owners, but I'm not sure the community has any value in this either. But you could use snapshots of in a repository manager. You could say, I got a dependency. I want to fetch it from my repository manager, and that repository manager will proxy the call to the source code system and just get a snapshot at that moment. You could do a full clone and fully proxy the repository. The end game, especially if your source is GitHub, which is the current, you know, beautiful baby associated with Git dependency management and Go, you could download a source file. That'd be a thing. I mean, there's probably at least a couple other things that you could do, but somebody needs to fix this. Somebody needs to get along. We need to have a way that this works consistently, if you want to have this happen. And if you don't, dependency management outside of the JVM is hard. And Go is a very fast growing, very, you know, very popular language. I like parts of it, except for this part, which I think is just a trash fire, and has been basically since the very beginning. But having this problem solved is going to be super important, or people are going to have additional trouble dealing with it. Now, that's all of my stories. So I'm going to give you my last words on this. So dependency management and caching helps protect you from the vagaries of the universe, from random chaos. There is some safety, but it has a cost. And, you know, you can decide whether you pay it or not. You need to store your output. No matter what you do, you need to store the output of your processes in some temporally namespaced system. That includes Go. You know, Go's inbound dependencies are source, but the output is always a statically linked binary. That thing needs to be saved. And you need to use it from the saved location. And that saved location can be a file store at S3 bucket. I don't care, but you know, it turns out that repository managers are a real thing, and you should probably try to make the use of those things. I believe that Nexus is a superior product in this space, especially around the security element. And Golang, the final thing I'm going to say about this is they really need to get their crap together about dependency management. Thanks very much for your time, and I appreciate everybody paying attention to my nonsense.
Mykel, always good. Curtis, come on in here, say hi to Mykel. I know you guys know each other, I do believe.
I do, and I caught the end of his talk.
Hey,
and I always love hearing.
Man,
I tell you what, I'm still sitting here waiting for the 45 years. That's what my soundbite was. I don't know if you were here, Kurt. Mykel says that if you're going to search the dependency tree in a Windows platform, you can. I'll see you in 45 years.
Resolve it. I'll see you in 45 years if you can do it all at once for various people. I had a lot of experience with that. The last couple of years, I had to do a bunch of Python work, and you know, I get it. People get attached to what they like to do, but man, that is a mess. And the packaging work that has gone on in there is so much better than it was in the past, and it has, in my opinion, quite a ways to go before it's solved.
The other thing you talked about, and Curtis, I thought this was interesting if you weren't here yet, but the difference between a vulnerability and exploitability. Those are two different concepts. I think that was interesting.
Or that in the end, if you have these things, right, like if you have something that's vulnerable but isn't exploited, then it's just danger waiting to happen, right? I mean, isn't that what we're looking at here?
Yeah, it's interesting. We're having this conversation here. We're at Micro Focus's Security Summit. We just had this exact same conversation an hour and a half ago in another room. So it's a hot topic today.
Right on.
All right, Mykel, people are waiting for you in the Slack channel to say thank you. Awesome presentation.
Thanks,
thanks for your help on the back end today.
Oh, you're welcome. Thanks, everyone. Y'all have a great day.